All right, let's finish this beast. We got that quiz coming up for Thanksgiving. Maybe I'll even be a little bit kind on it because I like Thanksgiving. And I forgot to play Gobble Gobble so far today. All right, so we are on example 8 on 2.4. And they give us this. And let's graph that first. Let's graph this first because that's what it tells us to do, right? So right away, I almost clicked on the screen to move it. What's my y-intercept for my exponentials are unchanged? Yeah, 0, 1, right? If I plug in 1 to this, I would get 1/3. If I plug in -1, I would get, what would I get if I plug in -1? 3, right? Because it's reciprocal. Do I need all these points? No, I just like to get an idea kind of what it's going to do, right? So I'm going to hover around there. There. That's my original 1/3 to the x. Y'all agree on that? All right. Let's be patriotic today. Veterans Day is fast approaching. All right. What am I going to do to that beast? For g of x, what's my graph going to do? Oh, I'm going to do, no, all right, fine. I'll do a first. How do I find the y-intercept? What do I plug in for y-intercept? 0. So that's going to be 1/3 to the -4 plus 2, right? What's a negative do to my function? Flips it, right? What's 3 to the 4th?
81.
81. Because it's 9 times 9, right? 3 times 3 is 9. 3 times 3 is 9. 81. So this is 83. So my y-intercept is the point 0, 83, right? Okay. Wow. So it's going to be like way up there. All right, now let's do B. I'm going to do B first to describe it, then I'm going to graph it, because that just makes sense to me, okay? What am I doing between these two graphs? What's this -4 going to do? You're right. We're going to go right 4. So a shift of 4 to the right, or a translation of 4 to the right, or a horizontal shift of 4. And what's the +2 going to do? Up 2. So vertical shift of 2, or a translation up 2, or however you want to put it. So if I go to my original graph, I'm going to take my original y-intercept. I'm going to go right 4, 2, 3, 4, up 1, 2, right? I'm going to take this point. I'm going to go right 1, 2, 3, 4, up 1, 2. I'm going to go right 1, 2, 3, 4, up 1, 2. What's going to happen to my asymptote? It's going to go up 2, right? So my new asymptote is y equals 2. There we go. How you guys feel about that? Is that process going to be the same with parabolas or rational functions or anything? Yeah. Yeah, certainly. Woo. You guys even know that reference? Three Stooges, right? No? All right. Wise guy. Oh, yeah, I just shifted it over. My bad. I don't know why I put it there. But the overall shape is okay. Oh no, another unlisted video. Wait, for this? For this? For my y-intercept? No, y-intercept, because when you plug in 0, it's always 1. The point 0, 1 is always your y-intercept unless you have an a in front. But we don't have an a in front. Nope, this problem's done. We'll forget about it. It's gone forever. All right. We good in 8? Was there? There wasn't a C, was there? Only on my report card. All right. All right, let's graph this beast now. Ooh, I like it. Graph this, label asymptote and y-intercept. Describe the transformation from 2 to the x. All right. No, I'll show you. It will. Let's do this first. Let's graph this. Where's my y-intercept on this one? How would I find it? Yeah, plug in 0. And what's anything to the 0? 1. So I have 0, negative 1/2, right? Am I shifting this up, down, left, right? So what's my current asymptote? 0. Let's plug in, I like to do 1 point before and after the intercept. Some books make you plug in like a bunch of points. I don't know, I've always just done 1 before and after. So what happens when I plug in 1 to this? What's 1/2? Negative 1/2 times positive 1/2. Negative 1/4. So it'll be down here. What happens when I plug in negative 1? That becomes 2. And 2 times negative 1/2 is what? Yeah. So I'm just plugging in the points. Like, now this would be a non-calculator, so make sure you can do this stuff without a calculator. Like if I plugged in 2, that fraction stuff, you know, that's gonna be negative. Oh, I'm sorry, negative 2. Because I don't care about 2, I care about this side. That becomes negative 1/2 times 4, right? Which is negative 2, because you have to flip that. That's enough. That's enough points. Maybe. And it's exponential, so that's going to be a pretty big curve. More, never mind. No, I digress. Not for the internet. All right. So, how does this graph, what's y equal to the x look like? That would have looked like this, right? Do you agree? Normal exponential passes through 0, 1. How could I write this or describe transformation from this? Is there a way I can rewrite this where I have a 2 in here instead of a 1/2? Reciprocal, so what can I do to my exponent? Are these the same function? Yes. Yeah. Head of the game. What's this negative do in front of this x? Flip over which axis, x or y? Y. So we're going to reflect over the y-axis or flip over the y-axis. What's this negative going to do here? Flip over, yeah, flip over the x-axis. Which makes sense because this is our original graph, right? So if I flip over my x-axis, it comes over here, and then I flip down and it goes like that. Is that what we got? It's a double flip. Flip and a flip. Or actually, it would be a rotation of 180 degrees. Don't worry about it. What else do I need? What would this do? Vertical is a stretch, shrink, compression. It's in front, right? So remember, stuff that's in front does what you think it does. So this would be a vertical compression or shrink. Or could I also use the term dilation of a 1/2, vertical compression? So that means we're making it shorter and fatter. And did we do that? Our other one jumped up quicker, right? This one took a little bit more time. All right. Look at that. My board's all bruised up. It's black and blue. Insert laugh track. All right. Vertical stuff is out in front. Horizontal would be by the x. Anything that messes left, right is up by the x in like the parentheses. Anything that messes up, down is on the outside of the function. All right. So far, okay? All right, let's get wild then. Hiya. All right. Whew. Here's our equation. Let's graph it with the transformation and then describe what's happening. Maybe this is actually a nice little review right here. This is a good little review. So this is my g of x is my f of x minus 3. That minus 3 is in parentheses, right? Which, if I recall, that means wherever I see an x, what do I plug in? X minus 3. So I'm taking my 4 to the x, but what am I plugging in for x? So that x minus 3 is in parentheses, right? It's in the exponent. So am I messing up, down, or left, right? Left, right. Not just left, right, but we're going to go right trace, right 3. Composite functions. We haven't even learned about composite functions yet. That's what 2.7 is about. All right. That's also something difficult about pre-calc is sometimes you need to know everything to know a new thing. Yeah. So my h of x is equal to f of x plus 5. What's my f of x? For the x. Then the plus 5 gets tacked on at the end. Is that by my x or around the whole thing? Around the whole thing. So that's going to move it up 5. Okay. This is kind of, you guys kind of remember this in Algebra 2? You had done stuff like this as well. Yes?
Why is the x minus 3 over the exponent?
Because we're taking this x minus 3 and we're plugging it in for x. Yeah, it's a composite function. It's in the parentheses here. We'll see it here too. We're going to do that again. So this is saying f of negative 2x. So that negative 2x goes, do you guys remember, do you see how this is f of x? We plug in an x. If it's x of negative 2x, we plug in a negative 2x, right? We plug that into our function. How many things is this doing to our function? 2, right? What's the negative do? Flip over y-axis or reflect. What's that 2 do? Dilates. It's going to be a dilation. It's going to be horizontal because it's inside by the x, right? Now this is where it's tricky. Is it a stretch of 2? It's a compression of a half because it is by the x. It's always opposite of what you think it's going to be. So it's going to be a horizontal compression or dilation of 1 over 2. It's 1 over that number.
Why is that 1 over 2?
It's just definition of horizontal stuff. Do you know how like if it's up here we went right 3 even though it's minus? If it's by your x, it's always opposite. Yeah, it's always the inverse actually, additive or.
So what if it was a positive 2x?
It would still be a horizontal compression of a half, but wouldn't be flipped. The negatives flip stuff.
Yeah.
All right, let's do something wild. All right. We have a negative 3 times our f of x plus 1 minus 2. Take a deep breath, guys. We can do this. What am I plugging in for my x? So it's going to be 4 to the x plus 1. Agreed? That negative 3 is not in the parentheses. It's out. It's outside. And that negative 2 is also outside. Okay. How many transformations are occurring? 4. All right, I'm going to start my list over here. What's the minus 2 going to do? Down 2, right? Because it's outside, so it's up, down. I'm going to work outside, inside. What's my negative going to do? Oh, yep. Reflect over x-axis. Yeah, it is the y-axis. No, it's x. Yeah. No. You got to think about this. This is the best way to remember it. If my graph is this, and I change all my values to a negative in front, where does it go? Underneath, right? So it reflects over your x-axis. When the negative's in front of the x. Because you're changing, if I plugged in 2, I'm now plugging in negative 2. So I'm flipping which side the x is on. So honestly, the rest of these are self-explanatory. Knowing which one to flip over isn't. Don't memorize it. Think about what's happening. Instead of plugging in 2, I'm plugging in negative 2. So I'm changing which side my x is on. Instead of getting a positive 2, I'm getting a negative 2. It's changing where my y is. Know what's going on. Don't memorize. Because if you try to memorize this stuff, what's going on, instead of knowing what it's doing, in a month are you going to remember that? No. But if you think about what's happening, it's easier to remember. Know the why, not the because. Now we have a 3 in front, so all our y's are going to get bigger by 3, right? So that's a vertical dilation. Ooh, let's use it this time. No, it's bigger. Yeah, because it's out in front. If I got 5 as my y value, I'm going to times it by 3.
So when it would be, so if it was like 1/2.
Yep.
What's the bigger though?
You can use dilation every time. A dilation can be bigger or smaller. A dilation of a half.
Just say dilation.
Yeah, actually, honestly, if you always use dilation and then just use the factor, you'll be fine. What? No, just mean it changed. A dilation is a change. They can be bigger or smaller.
Okay.
Trust me, I had a good geometry teacher. You guys didn't, but I did. We have one more. What's this plus 1 going to do? Left 1, right? It's opposite, because that's affecting my x, not my y. Because remember, this thing is my y, my f of x, so I'm affecting that on the outside. The stuff in here, I'm changing my x value. Phew. Done. Retiring. It's the last video.